All right, so we're going to get into stoichiometry. All right, don't forget to do your travelogue. Stoichiometry. This is the quantitative, this means numbers, study of chemical formulas and reactions. In Greek, stoichion means element, and metron means measure. So it's the measure of the elements. It's a number. Chemical equations are used to describe chemical reactions in an accurate, and convenient fashion. Shorthand communication gives a lot of information, a great deal, and you'll see in a little bit. So general equation format, this is what you could generally see. You see something plus something goes to something, or something goes to something. You're going to see this right here. All right, on the left side, this is the reactants. It's what you're putting together to make something, or what is the starting stuff. And then on the right side, you get the ending stuff, or the products, the finishing material. This arrow represents a chemical change, a change. A typical chemical reaction also includes any complete chemical equation. You get these right here, which are your phases: solid, liquid, gas, or aqueous. And then you have a balance. That means whatever's on the reactant side equals whatever's on the product side. It's all atoms are accounted throughout the whole entire reaction. So when you are doing these chemical equations, you cannot forget the diatoms. Anytime I say, like, you got a chlorine, you made a chlorine, you have to know that because it's a diatom, it's got to look like this, a Cl2. You can't just put chlorine. Like if I was to say you made a copper, you would just have a Cu, and that's it. There's no anything else. But for Brinkelhoff, or the 7 elements, the super 7 with H, you have to remember that you have to put a subscript 2 with it, meaning it comes in 2. All right. Phases. First task in mastering equations is writing the known correct phases for each substance. So solids are any and all metals, typically on this side of the reference table. Liquids, you're going to have, well, water is a liquid, just know that. Water is liquid. And then you have, on elements-wise, bromines and mercury are liquid. Your gases are all the nonmetals. And anytime you see aqueous, that just means solution. All right. So when reactants are dissolved in water before mixing, so say I put salt into water, a determination must be made whether the products form a compound only or will remain dissolved, aqueous, or precipitate out a solid. So this is, if I throw the salt in there, is it going to stay as salt? Is it going to stay as a solid, or is it going to dissolve? Soluble. These words you have to know. Soluble. These are substances that will remain dissolved in aqueous solution. Insoluble are going to be solids. So it's kind of like opposite. Soluble, dissolved, insoluble, solid. All right. Why is it soluble or is it not soluble? How can we tell? Well, I did go over this already once, stating that when you're looking at these, if it says it's exempt, that is why. If it is not exempt, you should say it's not exempt. So looking at silver nitrate. All right. First thing I'm going to do is I'm going to look down here for the soluble, see if it dissolves. Nitrates, no exemptions for nitrates, which means silver nitrate is soluble. There are no exceptions. How about potassium chromate? Let's look for potassium. K is in the first, so it says that it's a group 1 ion, which means it should be soluble, but I want to keep looking. Here's a chromate over here. And it says it is insoluble, turns to a solid with exemptions when it is combined with group 1 ions. So it's combined with group 1, meaning it is soluble, because it is an exemption for chromate. All right, PbCl2. So chlorine is in the halide group. So over here in my solubles, I look for a halide. Oh, there's my chloride. All right, let's look for lead. And we know it's a 2 because this 2 goes up here. So let's look. Lead 2 is right there. So it is insoluble or solid because it's an exemption to the soluble rule. All right, balancing equations, the funness of it all. All right, laws of conservation of mass. Atoms are neither created nor destroyed in chemical reactions. They don't come out of nowhere and they don't just disappear. Okay, so for a mass to remain consistent or constant, the same number of atoms of each element must appear on both sides, the reactants and the products of an equation. All right, for the reaction silver-chlorine to produce silver chloride. Once the correct formulas are written, subscripts should not change. So once I have all these down, silver by itself, chlorine, because it's a diatom, has to have the subscript 2. Then I've got AgCl2. Chlorine is a -1, and silver, it's not saying if silver is a positive. So we're looking, it looks like it's silver 1 chloride. Since we start with 2 chlorines over here, and each silver chloride uses only 1, the reaction will build 2. So to build 2 silver chlorides, 2 silvers must be supplied. So I add that 2 right here because of this. Now I need 2 silvers. To do that, I added 2, or a coefficient of 2 in front. These coefficients just multiply everything that's behind it by 2. So the numbers of atoms before the arrow have to equal the numbers of atoms after the arrow. Pardon me, a formula subscript applies only to the element which is attached. The coefficient preceding a formula applies to all elements in that formula, everything on that line. So it's just these 2. Doesn't mean chlorine's 2. The only reason I know it's a 2 is because of that subscript. So right here, it means everything after it is 2. All right, let's look at this right here. So balance the equation. Sometimes you need trial and error. I do it a lot. Get a scrap piece of paper. Rule of thumb, balance oxygen and hydrogen last. It will save your sanity. Easy adjustment may affect elements that already are balanced. So let's look at this one. You have aluminum plus oxygen gives you aluminum 2, or aluminum oxide. All right. Final numbers should always use the smallest whole numbers. So looking at this, I have a 2 here, so I need 2 here. I have 2 here, but I have 3 here. So I'm going to have to do something to make them even. I'm going to end up putting this is not balanced. I'm sorry, this is incorrect. All right, so I just fixed this one. So you can see there's a 2 here and there's a 2 here. So these match up right here. And then there is 3 here, but 2 here. How am I going to do it? The lowest common to get them together. So 3 times 2 is 6. 2 times 3 is 6. These 2 match up. Okay? All right, let's look at the next one. We've got PCl, or potassium chloride, plus water gives you hydrogen phosphate and hydrochloric acid. All right, so there's 1 potassium here, or phosphorus here. There's 1 phosphorus here. Matches out. Awesome. 3 chlorines, 1 chlorine here. Gotta put a 3. All right. Let's look at the hydrogens. I've got 3 and 3, that's 6. There's 2 here, so I'm going to want a 3 here. Okay, so now I've got 3 oxygens. I'm balanced. And here's a special thing. If there's a polyatomic ion that is on both sides, has to be on both sides, not just one side, disappear on the other. On both sides, you could keep them as like their own little element. Make your life easier. Don't waste your time separating them. So looking at this, we've got magnesium nitrate, sodium phosphate. Sodium nitrate, magnesium phosphate. I'm going to start with the magnesiums first. I've got 1 magnesium here, 3 here. So I'll probably add a 3 right there. All right, let's see my nitrates. So I'm not looking at this because that is part of the polyatomic. I'm looking at the number outside the parenthesis. So there are 2 nitrates, but I have to multiply it by 3. So there's 6 altogether. Well, I only have 1 nitrate here because there's nothing outside the parenthesis. So I'm going to put 6 in front of the sodium. All right, so I'm going to go back to this sodium. So I have 3 here. I'm going to need to add a 2 in front because 2 times 3 is 6. So I've got 6 and 6. Now I have 2 phosphates. 2 phosphates. It's balanced. All right, what I need you to do is do the worksheet on the formulas and figure out phases and solubilities. Then go to the balancing and classifying and do part 1 only. That's the balancing part. If you have questions, do not hesitate to ask me. I will help you out. Practice, practice, practice. It will help. All right? I hope you guys have a great day.